Well, thank you for the introduction and for everyone for being here. I'm a PhD student from Brazil, and first of all, I would like to thank all my amazing colleagues who helped authoring this paper. And nowadays, it's more common for our community to treat recommender systems as a sequential decision-making problem. The systems must not only predict the recommended items, but also adapt to user feedback and to evolving preferences in dynamic environments. And of many approaches that we can use in this scenario, multi-armed bandits became one of the standard types of algorithms. They work by balancing exploration, that is recommending novel items that the user might enjoy, with exploitation, that is recommending items that the user will certainly enjoy because of his tastes. And there are two primary ways to evaluate that. One of them is through online approaches, where you use A/B tests with real user interaction, and they tend to be the best approach because they are a measure of real-world performance. But in many cases, they're impractical due to costs and potential risks to hurt the user experience. Then offline is another one, also called replay evaluation, that uses historical log data, and it's a standard practice for benchmarking. But it also has some problems. The data is fixed because it's capturing the past, and it's a non-interventional problem. What you recommend does not change the user behavior. And the main problem is that in offline evaluation, unless you have the original logging policy recorded, exploratory actions often goes unobserved. They were not captured. You only have the positive ones. And this can critically impact the exploratory algorithms such as multi-armed bandits. But the literature shows that exploration is needed. Users normally engage with recommender systems to discover new recommendations, and that good exploration can enhance the user experience. There are two ways we can evaluate in an offline manner this to mitigate this problem. One is off-policy evaluation that allows the comparison with the original logging policy. And the other one is simulators that use mathematical functions to conduct control experimentations in simulated environments. But offline evaluation, even with its well-documented bias, continues to be one of the most standard practices. Our study then shows a bias in exploration versus exploitation, conducting a large-scale experiment focusing on linear bandits. For this, we compare 4 algorithms. One, which we call lean. It's a purely exploitative linear regression model. It's greedy. It only recommends what item achieves the best score for that user. And 3 multi-armed bandits that they all have a linear regression backbone, but they change in how they explore the items. The greasy lean used to be in lean TS. Some works with probabilities, other with upper confidence bounds. And we selected 9 datasets that are commonly used in the literature and we can find in many papers. They are from different domains and have different sizes, number of users, items, and interactions. And to conduct our experiments, we first split them into 2 halves. The first half was used as a warm-up for the multi-armed bandits and also to generate item embeddings using alternating least squares. We used these embeddings to generate the state representation, which were then fed to the multi-armed bandits, and its hyperparameters were fine-tuned. With the second half of the datasets, we divided into 10 equally sized windows, which we then sequentially iterated, asking for the recommenders to generate recommendations, capturing the user feedback that was captured in the past, so what the user consumed when that dataset was captured, and updating the underlying models. We aim to answer 3 research questions. The first one is how reliable are offline evaluation protocols in this manner. The second one is to what extent does purely exploitative models outperform the exploratory ones? And the third one is how hyperparameter optimization choices are influenced in offline protocols. Here are some results to help answering the first 2 research questions. These are the NDCG for a top 20 recommendation. We can see for each data set and for each window. And normally, the results follow a linear pattern, a linear trend that was delimited by the linear algorithm, the black line. In many cases, we can see that the linear algorithm outperforms the exploratory counterparts. sometimes like in Delicious or Retail Rocket, even with a big margin of advantage. And the only case where the results of the exploratory algorithm surpassed the exploitative one was in MovieLens 100K. Our insights show that it's a data set with a few characteristics such as small item subset and with users that consume a lot of items. So you have less exploration costs specifically in this data set. Here are the results for the aggregated results, not divided into the windows. And as we can see, although LinTS surpassed the linear algorithm in some cases, in almost 9% of the data sets, the linear algorithm, the purely exploitative one, was the best or second best, even being proven superior to LinGrid by a non-parametric Bonferroni-Dunn test. To answer the third research questions, we analyzed which hyperparameters were picked. And as we can see, for both LinGrid and LinUCB, the hyperparameter selected always converges to a more exploitation-focused ones. In only cases where LinTS selected exploratory hyperparameters, its results were normally poor. We also conducted an off-policy evaluation using the Open Bandit Pipeline, where we compared the results with 3 OP estimators, and in this case, the linear algorithm also outperformed the others. And our main takeaways and conclusions is that we know there's a problem here. We see that there's a bias, so we need to solve it. And we advocate for better and more realistic simulators. In the paper, we list a lot of simulators that we have now with its advantages and disadvantages, but we also advocate for more OP of policy evaluation estimators, more tailored to exploration, and the standardization of evaluation protocols. Because if we can measure exploration properly, we cannot be sure that our recommender systems are learning to discover new tastes for the users. Here are all the references using this presentation, and we have many more results, metrics for different case views in our official repository, along with the source code that is available in this QR code. Thank you all for the attention, and I'm open to questions.
So would you say this is mostly a limitation of the data that we typically have? We don't have data that's useful for evaluating these type of systems, or do you think the methods are actually flawed?
I think it's a mix of both. I think when we try to evaluate the methods using an offline approach, it does not matter the data if we don't use like a counterfactual evaluation. If we just conduct a traditional offline evaluation as it is normally done, you will fall in this same trap where traditional exploitative algorithms will surpass the exploratory ones. But also in this case in which we compare the linear regression that is used as a backbone for the exploratory methods, I think that it's also a problem that it happens because when you compare, like if you only compare the exploratory algorithms, we can assume that some of them will be better than the others. But all of them follow the similar linear regression, and the difference we can see then is not when they were going best, but when they're going worse than the others. Yeah. So yeah, I think it's a mix of both. I think there is a problem with data that I don't think it can be easily solved with only offline data, but also the algorithms, when they are built upon a foundational, they can fall in this trap that the foundational often outperforms the exploratory ones.
Do you see promise in the use of counterfactual or logged bandit feedback approaches as a way forward?
Well, when we started doing this research, we thought that the counterfactual was going to be the answer, but as you can see, the results, they didn't. The linear also outperformed in that scenario. So I think the way that the counterfactual evaluation normally occurs, it can also generate this problem when you cannot evaluate exploratory actions cohesively.
This makes sense.